Here we are, Sunday morning, damp, wet, nothing else to do outside, can't finish my project there. So I've got another project that should have been done a long time ago. Here is my XP14-030, and today I am going to add a compensator to this unit. This unit is matched up, or will be matched up, to a micro-channel downflow all aluminum Nordyne coil, which does not match the AHRI rating nor the coil volume of this heat pump. It's the combination I want. Obviously it doesn't work. It was installed for air conditioning and heat pump and worked in both, but I had to adjust the charge to get it to run in heat pump mode because the coil volume in the outdoor unit is much higher than the coil volume in the indoor unit. So today we're going to add a compensator to it, and I'll show you small videos as we go. Obviously I can't video the whole thing, but I'll have short clips of steps and stages. Obviously I've already got some cases off of this thing. I am going to strip the whole unit, probably the whole condenser coil, so I can get to the innards and add the compensator. And again, this will be a couple different videos. Alright, there it is. Looks a little bit different now. So this is just showing you stripped, obviously, condenser coil and all of the cabinet parts. And now I got it up on a table. I can get to it. I can add the compensator. The compensator is actually going to go somewhere out in here. I'm going to cut this pipe here, suction line coming directly from the condenser coil, and it's going to go through the condenser, and then we have to tee into the liquid line. So see that here in a couple minutes. Okay, so about 2 hours later, here we go. There's the compensator. Comes out, goes into the reversing valve. Obviously it's coming from the condenser coil, which I haven't put back on yet. I got one brace joint left to do. There's the 3/8 line, comes back here, ties into the liquid line, which be coming from the indoor coil, of course, in heat pump mode. Had to tee in there with not the right size tee, but it worked. So now we can start putting the condenser coil back on and putting it all back together. Okay, there it is, on vacuum. Been that for about 3 hours. It's been pulling vacuum. So obviously I'm using a 4-port manifold. Hooked up to my service valves. Cores are not in it. Stubs are brazed closed. Service valve open, so I can use the 2 ports without it being hooked to the system. So obviously I'm just pulling on the unit. There's my T going to my sensor for my micron gauge. Hooked to my vacuum pump. Vacuum pump has its own ball valve on it. A bottle of refrigerant. Break the charge when I'm done, or break the vacuum when I'm done with a little bit of charge. So I pull this thing down until it's below 500 or better, and actually I'm probably going to let it go a lot longer than that. There it is, right on the money, 500. But I'm going to let it go a little bit longer than that because it had been exposed today. It was very moist today, and POE oil sucks up moisture, so any unit I do for any customer is going to go below 500, and it's going to hold it for 15 minutes. So what I do is pull it down until it was below 500, and then I shut that valve off at the pump, turn the pump off, and it will have to hold that 500 number for 15 minutes or better. Do it to every system, always have. It's the way I've been taught. So there it is. All brazing done here on this unit was done with nitrogen, as it should be. Never brazed without nitrogen. So the compensator that I have selected for this unit, I select based on what I knew about the unit and how it ran. So like I said, I have it installed. I had it installed, and I've been using it for 2 seasons. With the factory charge in the unit, which is 5 pounds and something, 5.5 pounds, it ran fine as an air conditioner, good subcooling, worked fine, great delta T, everything worked. But when you switched over to heat pump mode, of course, all that liquid refrigerant in the heat pump, it can't be stored in that little microchannel evaporator coil that I have. So that's what the compensator is for. I had to remove about 2 pounds. If I remove 2 pounds from the unit, it works fine as a heat pump. So I selected a compensator that held 40 ounces, so a little bit more than 2 pounds. Should be fine because I can run even more refrigerant in air conditioning mode and still be okay. So we selected a compensator from some other manufacturer. It was a factory part in another unit, but we took specs off of the compensator, figured out what size I needed. Basically, it's how I selected the compensator, just based on its volume of refrigerant that it can hold. So there it is, all installed. Like I say, I'll pull it down. It can run, it's only 2 o'clock, so it can run all night if it has to. I don't care if it buries the micron gauge. The further down the better. Get that moisture out of that POE oil as much as you can. You know, there's a great debate about how much moisture actually comes out of POE oil, but if you let it pull long enough, it's going to come out. So again, there's the unit. It's done vacuum. Tomorrow's supposed to be a little bit nicer, so I should be able to reinstall the unit and finally get air conditioning back. I actually haven't had this unit installed all air conditioning season. It's May 2nd, or is it May? It's May the 5th right now. So I've had a couple days to come home and it's 87 degrees in my house, so I'm looking to get the air conditioner back installed. I'm sure my wife will appreciate it a little bit too. So. But we'll install it, and I don't know if I'll be able to test the heat pump this season. Obviously, I'll be able to charge it up and make sure the air conditioner works. And if we get a day where I can turn the heat pump on and see how it works, then I might make another video. Otherwise, I might have to wait until fall. But it's all back together, and that's about it. What did want to show. Got my stubs brace closed there, like I say, so that my service valves are open, no cores in it, so it's pulling vacuum. And what I'll do is, when it's done pulling vacuum, I'll actually shoot a little bit of 4-ton in there, and that'll take it off of vacuum, put a positive pressure on it, and then I'll close those service valves down, just like the unit was brand new. It just won't have very much refrigerant in it. But it'll be all clean with good refrigerant, a little tiny bit holding charge. And then I'll unbraze those stubs and install the unit back in my house, set it back on the pad, and braze it in. And then of course I have to pull vacuum again on my line set and my indoor coil, which won't take any time at all. But it's been on vacuum for 3 hours, and you saw there earlier it was at 500. Like I say, I'm going to go a lot lower than that. No sense in rushing this. I've got all afternoon. Nothing else I can do outside, so just let it pull down, and when it's done, it's done. Okay, here it is. Unit's running. It's about 58 degrees outside. It's only about 64 inside. Running about 110 psi, 36 degrees saturation temperature, and almost 300 psi on head, 95 degrees saturation temperature. It's on my liquid line. So I could use a little bit of refrigerant, which is good because I have a factory charge in it. And I could have used a little bit more in air conditioning mode, and I can use just a little bit more in heat pump mode. So the compensator is doing its job, taking up that excess refrigerant. At these temperatures, I would have been well out past 450, 500 pounds of pressure before I put the compensator in with factory charge. So there it is, it works. And it is working pretty good. I'll add some more refrigerant to it in cooling mode, get the subcooling up a little bit, and it should be fine.